Welcome again, Mindsetters. Now it is time for geometry for grade 11, still doing mathematics. Hope you're all ready, and this show is proudly sponsored by Macmillan. And now I am joined by Dina. How are you, Dina?
Hello, Abraham. It's nice to be with everybody again. Abraham said it all. It's analytical geometry, so we're going to revise some of the grade 10 concepts and introducing that little bit of new stuff that's peculiar to grade 11. So stay tuned.
And guess what? There's also Lidilo on the page already saying, I really can't wait for this lesson. Guys, it's going to be awesome. It's going to be great geometry. Dina, go to your board and we get ready.
Thanks, Abraham.
All right, talking about readiness, Mindsetters, I hope you're also ready. Take your pen and paper next to you, all you grade 11s. For now, let me give you a link for Facebook. It is facebook.com/learnextra. That's where you can get in touch with us, communicate with us, get your questions over the Facebook page, and we'll try by all means to help you through. Our website for notes, and the notes are also going to be on the page. It is simple, learnextra.co.za/live. Guys, I'm so ready. Get all your questions ready and pump them in because we're here to help you. Dina, take it away.
Thanks, Abraham. So as he said, you need to just keep posting your questions so we can help you out. And obviously, I love the fact that everyone's also helping each other out as well. You would have found the notes on the page, as Abraham's explained. So I'm going to go through some of the theoretical aspects that you've already covered in grade 10. I just want to give you a little bit of a synopsis of what we're going to be covering in the next hour. We're going to look at some of the theoretical aspects. I'm going to be doing an example, and then I'm going to be doing 2 questions as well that's already posted on the page. So if you've already attempted it, you'll be able to see whether you've got it right. And for those of you who haven't done analytical geometry yet this year, never mind. It's coming your way soon. Just be patient and just work with me while I do those questions with you. So let's start off by having a look at what did you cover in grade 10. So in this lesson, we're going to work through a number of examples to fully grasp the major key concepts in analytical geometry. The key concepts we're going to look at are things around gradient, parallel lines, perpendicular lines, how we get the equation of a line segment, the distance of a line segment, and the midpoint of a line segment. So none of these are new. These come all from, in fact, gradient, parallel lines, perpendicular lines come from grade 9. The equation of a line we did in grade 9. The distance of a line segment, you may have touched on it in grade 9, but we really looked at that in grade 10. And we also looked at the midpoint of a line segment in grade 10. So really what's new is this, let's see, we'll use this color. The new aspect is what is inclination. So that's really what's new to grade 11. And then we're going to look at some of the properties of geometrical figures, because anything that we do in analytical geometry, it's going to involve some of the geometrical figures. So that's where we're going. Revision of grade 10, and then we're going to introduce some inclination. Okay, so I'm taking my notes from an excellent book called Clever, Keeping Math Simple. And it's the grade 11 book, and it's put out by Macmillan. So if you want to get some of the examples and notes in that book, they're very, very good. So the summaries are taken from Macmillan's book. And the gradient formula we all know is the distance in y divided by distance in x, where your x of a is not equal to x of b, otherwise you'd be dividing by 0. So the gradient formula is really what we call a rate of change. How quickly is y changing with respect to x? So we've got what we call a change in y over change in x. For those of you who do science, you will know that most concepts revolve around some sort of change, and we talk about gradient as being a change concept. Then we've just given the gradient between these 2 points in 2 different ways. You can talk about the difference in y's, whether you took y of p minus y of q, or x of y of q minus y of p is irrelevant, as long as you keep the pair of numbers together. So you would need to keep your q points together, and you would need to keep your p point together. So you couldn't say y of q minus y of p, and then the next line say y of p minus y of q. You need to keep it consistent. If you've spoken about Q first, you speak about Q in the denominator first as well. So that would be the gradient. Then we have the gradient of a horizontal line is just 0. So peculiar gradients that we get are a 0 gradient would give me a horizontal line, and a gradient that's undefined is also particular to a line that is vertical. So only vertical lines have got undefined gradients, and horizontal lines have 0 gradients. And then something about parallel lines. What do we know about parallels? If I have two lines parallel, then their gradients are equal. So any lines that are parallel exhibit equal gradients. And so you can begin to see how we're going to associate geometry with what we call Cartesian plane understanding. Because if I take a set of parallel lines and I had to take another set, let's create another set of parallels over here, and these lines are parallel, then what shape have I created? So I've created a four-sided figure that's called a parallelogram. And that's where the two are going to meet, where algebra and geometry are going to meet, is when we are going to be asked to prove that those lines are parallel, and we are not going to be looking at the angles to show that we've got corresponding alternate angles equal, but we're actually going to do it through the fact that equal gradients mean we have parallel lines. So the word analytical is quite a random word, but it really means that we're analyzing the geometry by using an algebraic process and not just a Euclidean or the Euclidean axioms to show that these geometric figures possess their properties. We really are showing through some algebraic mechanism, and that mechanism will be through the gradients. And then lastly, so we've looked at the formula for gradient, we've looked at zero gradient, undefined gradient, equal gradients. What about when lines are perpendicular? What happens then? If lines are perpendicular, then the product of the gradients is -1. So the product of the gradients is -1. So what happens if you look at it closely is that for this line to be perpendicular to that line, they can't have the same signed gradient because the one is leaning in the opposite direction. So their gradients will always have to have a different sign. Lines that are perpendicular will show that the two signs are the same, whereas if they're parallel, they're leaning in the same direction, hence they're going to have the same sign in their gradients. With this one, what we mean about the products being -1 is that the one is a reciprocal of the other. So the gradient of the one line will always be the reciprocal of the gradient of the other line. So we have that product being -1 when that process is in place. Okay, so we have the summary, and we now look at the other key concepts, which was the distance and the midpoint. So the distance between 2 points is always defined by this formula. It doesn't change, it's fixed. It's PQ can be written, or PQ squared can be written as the difference in my x squareds plus the difference in my y squared. So it's kind of related to the gradient formula in that it's the difference of x, difference of y. But in this case, there's an aspect of Pythagoras there because we're bringing in the squared value. So that comes from grade 10. That's not new to you. And then the midpoint is also not new. So we've got that to get any midpoint, we would take the sum of the x's divided by 2, the sum of the y's, and divide by 2. So the concept in mathematics that we're using here is that if we want a middle, we would always take an average of 2 values. So that's why we're adding the 2 values to get our middle value, and hence the sum divided by 2. Okay, so that's the midpoint. Right, so up to now we haven't done anything new. This is where something new and particular to grade 11 comes in. And that is the word inclination. So if you imagine, when I talk about how inclined is a line, you would have to have a reference point. I don't just say inclined. You would be in language, we talk about something's inclined if you are comparing it to horizontal. So we would have maybe a 10 degree, a 20 degree, a 30 degree inclination. So an inclination refers to an angle that a line is making with a horizontal. And we're going to talk about that inclination, that it can be an acute angle, we can have perpendicular lines, and then we can have lines that are inclined at an obtuse angle, and then we've got a straight angle. So lines can show an inclination of an acute angle, 90 degrees, obtuse, and 180. So an inclination is defined as an angle between 0 and 180 degrees. So the definition then of inclination is that it is an angle. And how are we going to calculate that angle mathematically? Well, we've got a definition here for you. And we say that the tan of the angle that you're working with, so if this was theta, that the tan of this angle is the same as the gradient of the line CD. Note that the gradient of CD is positive, and thus tan theta is positive. And so we're going to get an acute inclination from 0 degrees measured to that angle. And then we have this angle over here, which is the gradient of that line is negative. So tan theta is equal to the gradient of PQ, which means here that tan theta is going to be equal to a negative value, which is going to give us an obtuse. So every time that tan theta is positive, we're going to get an acute angle. And every time tan theta is negative, we're going to get an obtuse angle. So the inclination is going to be calculated by using the ratio tan theta. And just to show you where that comes from, if I had a point there over that, I would be getting, let's say, to get this angle, I would need the change in y, and I would need the change in x over here. So just don't know where I'm getting this y from. Change in x. So which ratio connects y and x together? That would be my tan ratio. So the tan of theta is my y over x, hence my tan theta is equal to the gradient. Now these formulae, the distance formula, the midpoint formula, and the inclination formula, they are on your formula sheet. So when you need help, just consult that formula sheet. Right, so let's see our definition. The inclination is always defined as an angle theta, is such that theta, okay, let's just correct this here. We have theta is between 180 degrees. Remember earlier I said to you it's an obtuse angle, or it's 0 degrees. And tan theta is positive when the gradient is positive, and tan theta is negative when theta is obtuse, in other words. So here we're actually just talking about an acute angle, and here we're talking about an obtuse angle. Okay? Right, so right, tan theta is undefined, but we would talk about a vertical line if theta was equal to 90 degrees. Right, we've done a lot of discussion. Let's look at our first question. Again, this is from Macmillan's book. It's on page 104, and I'm doing question 2. Okay, the information that's given, we have a point P whose coordinates are negative 5, 7. We've got a point Q whose coordinates are 6, 4. We've got a point R whose coordinates are 4, negative 2. And we've got a point S whose coordinates are negative 8, negative 4. And these are the vertices of a quadrilateral. Okay. So notice how we are combining geometry. We're drawing geometrical figures, and we're going to draw on their properties to be able to explain or to be able to answer some of the lengths, midpoints, and things like that of those figures. Right, the first question is to prove that PS is perpendicular to PQ. And we're going to go through question by question. So let us see if we've got this. There we go. All right. First question, prove that, let me just redo this. PS is perpendicular to PQ. Okay. So you may be saying, well, how do I do that? mathematically, how do I prove that two lines are perpendicular? Well, two lines are perpendicular if I could have that the angle where they were meeting, so here's PQ, here's PS, so basically I'm looking at this angle. So with geometry, always got to remember, I don't prove words. So if I've got a wordy statement, I've got to translate it into a mathematical statement that involves an equal sign. So I'm really showing, where I'm really wanting to get to is to show that P is 90 degrees. Okay, so that's really what I'm trying to do. Now, geometrically, you can do that in a number of ways. You could use Pythagoras to find a 90-degree angle. You could maybe have other geometrical shapes, like you would already have a square or a rectangle that's got an interior angle of 90 degrees. So there are a number of ways of drawing on a 90 degrees. When you're doing analytical geometry, can you recall from earlier on, what did we say about lines that are perpendicular? Do you recall that perpendicular lines exhibit a very special property, that the product of their gradients is -1? Okay, so we are going to translate this into meaning that I really want the gradient. Okay, that means find the gradient of PS, find the gradient of PQ, and when you multiply them together, you must get -1. Okay, so remember I said you don't prove words, you prove equal signs. Either we're going to show that P is 90 in some way, or when we're on analytical geometry, we are actually wanting to look at gradients. Parallel lines will use equal gradients, perpendicular lines will use the product of the gradients. So there we go. That's where we're heading towards. Okay, and I'll leave you there. Abraham?
Well said on that one. Just before we get to the ad break, I'm really getting the vibe from the young mindsetters and also matriculant saying, I take this session as a revision, and I think it's just a great one. So thank you very much, Gina. Let's keep it on that note. While on it, mindsetters, still get your notes on our website, which is learnextra.co.za/live, and also get to Facebook and give us your questions, give us your thoughts about the show, enjoying the lesson, just like Linogu said, that he is really enjoying the teacher today. Is just wow. Keep those comments coming. Our Facebook page is facebook.com/learnextra. See you after the break. Do not dare touch that dial. Welcome again, mindsetters. Hope you're all chilled now and still trying to figure out the sums that we're doing today on geometry. And as some mindsetters were saying that geometry is just free marks. Would you agree with that, Dina?
It's free marks, but you still must be accurate.
You must still work hard on that one.
Yeah.
And also on some of the comments that I've been getting saying, we got lost on the last question. Guys, Dina hasn't done anything on that question, so she'll still get on that question. But let me just give you the links again to our Facebook page. It is facebook.com/learnextra. And our website for these free notes. Some guys were complaining saying, we really can't see the tables very well. Guys, get the notes, and those tables are on those notes at learnextra.co.za/live. Dina, take it away.
Thanks, Abraham. Yes, those summary tables are awesome, and they can be found on the web page. So please just get there, because you won't miss out on anything if you can just get to that link.
Well said. As you take it away on that one, let me also tell our lovely grade 11s that this show is proudly sponsored by Macmillan. All those notes are resources from Macmillan.
There we go. Thank you. Right. So for those who were struggling, I have just given you the points of a quadrilateral, and we're going to work through some questions on that quadrilateral. And the first one was, prove that a set of lines are perpendicular to each other. And we had discussed that we do not prove words. We've got to unpack what those words mean mathematically, and we've got to get an equal sign, because what we prove are equal signs. So we had just unpacked that and said, to prove perpendicular lines analytically, we're going to try and prove that the product of the gradients is -1. So really what we're looking for is the coordinates of that figure. So Q is 6, 4. We're then looking for, we've got PQ, PS, and we're looking for point S. So point S is -8, -4. -4. And we're saying that we'd like the gradient of PS. How do we work out the gradient of PS? And grade 11s, you at this stage don't need to write down the formula. You need to use your fingers and be accurate. So it's the change in X, or the change in Y first, 7 plus 4. And the Y value, the X values would be negative 5 plus 8. And the reason some grade 11s are saying that analytical geometry is just 3 marks is because it's so numerical. There's a couple of X's and A's and B's and things like that, but most of the work is literally taking a formula and substituting in. We're working out the gradient. We substitute into the formula. So be very accurate. A lot of people lose marks on the accuracy because they write change in X over change in Y. So you need to also be sharp in terms of accuracy. Right, so we've got here that this is negative 3 over 11, or 11 over 3, should I say. Does that make sense? If the gradient of PS, we always go back to confirm. PS has got a positive gradient. My gradient is positive, so possibly I've got the correct gradient. What about the gradient of PQ? What would that be? Change in Y, so 7 minus 4. And I've started with this point, so I'll start with this point in the denominator. Use your fingers to just point to them. Minus 5 minus 6. Minus 5 minus 6. So I get a 3 over a negative 11. Okay, and then we're going to multiply them. Remember, we're proving this. So we are going to multiply what we got, gradient of PS times gradient of PQ. What do we get? 11 over 3 times 3 over negative 11. So we get what? A negative 1. Be careful that you don't just write that equals negative 1. You've got to show some form of calculation how you got there. And so as a result of those products being having that relationship, we can therefore say that PS is perpendicular to PQ. Okay. Then our next question was, what is the equation of PR? And my equation PR, here's P, there's R. The equation of a line is Y minus YA equals gradient times X minus XA. Okay, just want to see if we actually have that in our notes. Just go there. Not sure if we looked at that. Extend page. Okay, it seems to be missing from our notes, so I'm just going to give it to you here. There we go. The equation, and maybe this is also new in grade 11. I'm not sure if you've actually covered it in grade 10, but the equation of a line segment is Y minus any point A that you've chosen equals gradient times X minus the X of that point that you've chosen on the line. So that's my gradient and that's my point. So if I look at PR, I have 2 points. What can I work out? My gradient. And then I've got 2 points. I can choose any of those points to substitute in. So over here, the gradient of PR would be, use your fingers for accuracy, so 7 plus 2 is 9. And negative 5 minus 4 is negative 9. So the gradient of PR is negative 1. So at this stage, we have what M is. And if we keep going, we then just need a point. And I'm going to choose 4, negative 2, so that my equation doesn't have an A in. I'm giving that to you as just another point. My equation will be Y minus negative 2, the point I've chosen to substitute, equals the gradient which we worked out, which is negative 1, multiplied by X minus 4. Right? And now you can multiply that out. So Y equals negative X plus 4 minus 2 would be plus 2. So if I go up to my picture to just confirm, I've got a negative gradient and I've got it cutting at 2, which kind of seems to be correct in terms of visual accuracy because it's a negative gradient and it's cutting on the positive y-axis. So that's the equation of my line. So I've actually substituted point R, and yeah, let's leave it at that. The next subsection to work with is what are the coordinates of K, the y-intercept of PR. So if that's PR, and we've worked out that its equation is y equals negative x plus 2, then what are the coordinates of K, which is the y-intercept? So what are those coordinates there? Well, if that's the case, then according to our calculations, K is the constant of that equation. So K is 0, 2. Okay, and then let's get to something that's new to grade 11, and that's the inclination. What is the size of angle T1? So if we mark off angle T1 here, what is the size and how are we going to do that? Well, earlier on we defined that to find the inclination, we have to equate the gradient of the line, so it's the gradient of PR, to the tangent of the inclination. So it's the tangent of T1. So if we do that, we've just worked out, remember PR's gradient was negative 1, we've just worked it out. So therefore we have the gradient, actually we don't have that, let's just say that tan of T1 is equal to minus 1. Therefore, we can now use our calculator to find out. Some of you may know that already. You may be quite sharp and you may be saying, no, you know what the ratio is of negative 1. For those of you that don't, we can go and find the angle that gives us negative 1. Okay, it gives us negative 45, but something to be aware of. There's no way that that angle is negative 45 because remember in trig, negative angles are measured in the opposite direction. So it's not measured in an anti-clockwise, it's measured in a clockwise direction. So that angle is definitely not negative 45. But if I take 180 and I minus 145 from that, then the negative 45 is actually the angle that's rotating in the opposite direction. So that angle is 135. So you are given the quadrant 4 angle and you've got to convert it into a quadrant 2 angle because we need the obtuse angle that gives us negative 45. So be careful with your calculator. It's not going to give you a negative, it's not going to give you the obtuse angle. You need to calculate that angle. All right, so we now have that this angle is 135. And the next question is to determine what is the size of P1 and where is P1? P1 is over here. So we're looking for this angle here. And you may be saying, well, how are you going to do that? Because I need lines to be inclined to the x-axis because the inclination is defined on that horizontal line. So P1 I can't calculate because it's not sitting on the horizontal, but can you see that this angle over here is sitting on the x-axis? So in that case, we could work out the inclination, V1, and what would that be? Well, I always need the gradient. So the gradient of PS would be change in y over change in x. I think we found that out earlier. So it's 7 plus 4, it would be 11, and negative 5 plus 8 would be 3. So it's actually 11/3. The moment you've got the gradient, that would be equal to the inclination. So it's tan of V1. And again, if we use our calculator, we can work out what that angle is. Let us just clear that. And to get the angle of that fraction, 11/3 would give us what angle? 74,7, and I think 74,7 is pretty useful, so we'll take that as 70, get a green pen, 74,7, was that right? Let's just check it again. Yeah, 74.7. So now that I've got this angle and I've got that angle, anything come up? Anything that you see? Let's use the blue pen. If I trace along P1 and I trace along that line, anything interesting pop out? I see something interesting. That 135 is actually the exterior angle of that triangle. So I could use that information to work out what this angle is, because the sum of those two would give me 135. So if I just take away that from 135, I get 60,3. So this angle over here is just 60,3 degrees using the exterior angle of a triangle. So if we were to actually set up a solution, we would say that we have found that V1 was equal to 74,7, and we found that relationship between P1 and V1 were equal to T1. It was an exterior angle of triangle, and we therefore have P1 is equal to 135 minus 74,7, which gives us our 60,3. So that was angle P1. So notice how we were able to work with the inclination. Inclination are all the angles that are on that horizontal. And then to work other angles, we need to connect them via some of the geometry that you've done in grade 8, 9, and 10 as well. So yeah, very interesting. Okay, so here's the table that summarizes all of that for us. I know some of you were saying that you can't see the table, and this is what I was talking about when I said the equation of a straight line is the change in y's is equal to gradient times change in x's. So I would really suggest that you just download that from the website. Just see, we are there at the end there, so let's go on to... Right, I said that I was going to go and look at some questions. We'll start off the next question before we go on to the break. So let's look at the information that's given. Again, we're taking it from the textbook, page 104, and this time around we're doing question 10. The diagram that is found has got points L is 3, 4, M is negative 3, 0, and N is 5, negative 2. They've also given us that P is the midpoint. Look very carefully how that is marked on the picture. If P is the midpoint of a line segment, then the segment from P to M is going to be the same as the segment from P to L, so that gets marked on the diagram straight away. And also Ln cuts the x-axis at E, and they've actually defined for us that the inclination from 0 degrees all the way to the line, they've defined that as theta, is the inclination of that line Ln. So now some straightforward questions. What is the length of Mn? And you should try and beat me to getting to that formula. What is the formula for the distance of a line segment? And I don't like to use that big square root because I'm writing square roots forever. So I like to just say the square of Mn, if you just look at that squared, would be the change in the y values and the change in the x values. So it's 5 plus 3 squared. So it's 5 plus 3 squared. And then you add on the difference in the y's, which is 0 plus 2 squared. And you just simplify that in the squared form, so that would give me 64 plus 4, which is 68. So Mn is 68. And then your calculators are very, very bright, and they'll be able to give you that in simpler third form. So Mn would just be the square root of 68. Can you see now my square root is just tiny? It's little. I don't have to have those massive square roots coming along. And that gives me 2 root 17. So that is the distance of Mn. Okay, we'll take a break there, Abram.
All right, still saying that we are learning so much. There are just 2 comments. One from Success Mkonto saying, I'm really enjoying this show. I just wish she was my maths teacher. Awesome, nice one. But we're going to take a quick commercial break. We'll see you after the break. Keep those questions coming over Facebook. We are facebook.com/LearnExtra, and over the website it is learnextra.co.za. This is a show proudly sponsored by Macmillan. See you after the break. Welcome back, Mindsetters. Hope you're all freshened up now and still ready to learn more. There are a couple of questions that Dina has to go over before we get to more serious stuff. The first one is from Lucky saying, is inclination always on the positive x-axis?
It's a very good question. How do we define it? What is the laws that govern inclination? And yes, it's always measured. If this was my positive x-axis, it's always measured from that, and it goes inclined in an anti-clockwise direction. So like you measure an angle in trigonometry, you always start measuring an angle into the quadrants by starting on the 0 degrees. So that's why we're measuring it on a positive x-axis, because that's our 0 degree line, and that's where we will begin to rotate from. So yes, inclination always gets measured that way. So inclination would not be measured from the negative x-axis, because we don't measure angles like that. So basically, the way you use an angle in trigonometry is the way that we are measuring an angle here as well, always from the positive x-axis. That's correct.
Well said. And the last one for now from Lakim Msibi saying, I really don't understand, where does that 135 come from?
Okay, the 135, and just for the other viewers who may have just tuned in, I want to go back to that angle earlier. Let's see where, there we go. Where tan of T1 was -1, where do I get 135 from? Remember that if a tan ratio is negative, your calculator is programmed not to give you the second quadrant angle and not to give you the positive fourth quadrant angle. Your calculator has been designed specifically to give you the fourth quadrant angle, but the negative angle. Okay, so just in terms of a trig revision question, let's just go here. So if we have this angle over here to calculate, then this is an obtuse angle. But if tan theta is equal to -1, your calculator, what does it give us? It gives us -45. Where is that angle? We need to understand the calculator. Where is this angle? So the calculator is going to give us this angle over here. That is -45. Okay. Now, through a process, and I think I've made it bigger than -45, but nevertheless, you'll understand that's -45. So every single ratio that's negative, tan has been programmed to give you that angle in that quadrant. What we're now saying is if we take this line across, then these angles are vertically opposite, so that's also -45, that angle there. So to get this left over here, to get this angle here, we would say that it's 180 take away this 45 degrees, so 180 take away 45 will give you the 135. So to get the obtuse angle, I always have to take 180 minus that given angle in the fourth quadrant in order to get the obtuse angle. So that's just a process of being able to find obtuse angles, because the calculator hasn't been programmed for that. Okay. So Abraham, can we carry on?
Yes, please.
Good. Right, so where were we? I think we were about here. Let's just see if this is where we were. We were going to work out the length of MN. Yes, we did that. And then we were going to work out the midpoint. Okay, P is the midpoint. So how would you work out the midpoint? Now, the midpoint's the easiest part because we have the sum of the coordinates divided by 0, sum of coordinates divided by 0. 3 minus 3 is 0, divided by 2 is just 0. So this point over here is 0. And the sum of the x's is 4 plus 0 is 4, divided by 2 is 2. So midpoint, sum of coordinates divided by 2, both in the x and in the y. Okay, so that would be the midpoint. Equation of Ln. There's Ln. Let's just color that in a different color. There's Ln. And what's its equation? And again, because you've got 2 points, what can you work out? We can work out its gradient. So gradient of Ln is equal to the change in y, 4 minus 2 is 6, and the change in x, 3 minus 5 is -2. So the gradient of that line is -3. That is great, because now the equation of the line, I can use any of these points. Remember earlier on I gave you that equation, y minus a y value, and let's choose this point. I think I like that point. It doesn't matter which one you choose. I'm opting for that. So we've got 4 equals the gradient multiplied by x minus the x of a, which is x minus 3. So we've got y equals -3x. I'm going to multiply that in. I get a 9, and a 9 plus a 4 is a plus 13. Okay, so that's our n. I can see it's quite a steep line, so I'm saying it's going through plus 13. It kind of is reasonable for that to happen. Okay, what question do you think is going to be asked next if I've worked out the gradient of Ln? Can you see that inclination theta, as somebody said earlier, is it always measured from the positive x-axis? Yes, it is. Always from 0 degrees, measured as in trigonometry. So the value of theta correct to 1 decimal place. So let's fill that in here. We would have that the tangent of the inclination is equal to the gradient of the line, which in this case we worked out as -3. Now, the tan ratio is negative. What are you expecting to happen? The calculator has been programmed to give you a negative angle, fourth quadrant angle. We are going to do some geometry, vertically opposite angles, so therefore your obtuse angle is 180 minus that calculator angle that you've been given. And so theta will then be obtuse, and my obtuse angle is going to be, we're going to use our magic machine to work out that we need a -3, and that gives us -71. Remember, that is the fourth quadrant angle. I need to add on 180 to bring me back to obtuse, so it's 108,4. 108,4. Okay. So a reminder that your -71 programmed calculator always gives you a fourth quadrant angle. I can't get away from that. It hasn't been programmed in another way. And to get to the obtuse, I add on 180 degrees. Right, and then the inclination of ML correct to 1 decimal place. Where's ML? Where's ML? There's ML. So we've got this line here, ML. So the inclination of that we could actually call M1. Okay, so let's work with the gradient of ML. Change in y over change in x. Change in y, 4. Change in x, 6. So the gradient is 2/3. So magic machine to help us work out what the gradient is. I mean, what the angle is, the inclination, is of 2 divided by 3. And we get 33,7. So that's 33,7. So that's the inclination. Okay? It is acute, so it's not giving us that negative. And then finally, we can work with the size of MLN. So the size of MLN, okay, this does not lie on the x-axis, but notice very carefully, if we look around, we did work this out earlier as 108,4. So let's fill it in, 108,4, which means again we've got that exterior angle of a triangle, minus 108,4. Minus 108.4, and what do we get? 74,7. So this angle over here is 74,7, working with the exterior angle of a triangle. Okay, so really inclinations as a review can either be acute or obtuse, because the connection between the inclination and trig is that tan of theta is equal to the gradient. We're going to have some tan ratios are negative, some tan ratios are positive, and if they are negative, the calculator is going to give you a fourth quadrant angle, or a fourth quadrant angle, which you need to convert into an obtuse angle. Okay. Right, so we can leave that there. And now we can go on to the next one. Again, from Macmillan's book, clever, keeping math simple on page 104, and we're doing question 8. We've got a triangle ABC where the coordinates of A and C are -4, 6, and 8, 2 respectively, and we have the coordinates of D as 0, -2, and it's also the midpoint. We like to highlight words like that, midpoint of BC, because it's giving us a lot of information. Oh, and here's another midpoint. We've got E is the midpoint of AB. F is the point 6K. Oh, look how interesting this now becomes. We've got parallel lines. And what do we know about parallel lines? We know that the gradient of FC, is equal to the gradient of AD. So, we've got midpoints, we've got parallel lines. Let's go see what's happening on the picture. Right, so they're the coordinates. And we have D, the midpoint. You've always got to check if the wording that's been given has actually been marked on the diagram. So D is the midpoint. They've given us that that segment is equal to that segment. E is also the midpoint, so we can make that segment equal to that and give us that. So we can put that on. They're different lengths, okay? And we've got the parallel lines. So we've got all the information that they've given us. Right, first question. Determine the coordinates of point B. What are the coordinates at B? Okay, well, if D is the midpoint, we worked earlier with going to find the coordinates of the midpoint. Now we're looking at finding the coordinates of an extreme point, an end point, whose coordinates of the midpoint we do have. Nothing impossible for a mathematician who is able to work in or out of that same problem. So coordinates of B are really, we should set it up as the sum of the two. So it would be 8 plus x of b, and we're going to divide it by 2, but then we have the answer. We know that it should be 0. So we set up one little x equation, which would give us an x of -8. And we've got a y equation, which is 2 minus y, or 2 plus y, sorry, over 2 is equal to, what is our coordinate of the midpoint? -2. So in the end, we get a y value of times 2, -4, minus 2 is -6. So we get a b of -8, -6. Okay. So that's very powerful, because you're not always going to find the same thing. The questions aren't phrased in the same way. But we can work around those questions by saying, well, I haven't got this information, but I've got something else that's useful. So that's exactly what's happened here. Give the coordinates of E, the midpoint of AB. Well, now, hopefully, our B are correct. So how would we work out the coordinates of E? Okay, so we would have -8 and -4 is -12, divided by 2 is -6, so that would be our x coordinate. And -6 plus 6 is just 0, so we'd have this point as the midpoint of that. Okay, then prove that ED is parallel to AC. Now, you could have proved this in many ways because there isn't a specific way, but remember earlier on I said you do not prove symbols, you don't prove words, you prove equal signs. So this could be translated into that I want the gradient of ED to be equal to the gradient of AC. Okay, so that's really where I'm going. What is the gradient of ED? What is the gradient of AC? Some of you may be there and you may be getting very excited because you've seen certain things. You've seen from grade 10 that if I have a line joining the midpoints, we don't want that line there, joining the midpoints, that line is parallel. That's called the midpoint theorem in a triangle. Can you see that? So you could have used some geometry, theorems that you already know, to prove that, okay? But if not, then you would be working with the gradients. And if we work with gradient of ED over here, then we have change in y would be -2 over change in x would be 6. So we've got gradient of ED is -2 over 6, which is -3rd. And we've got the gradient of AC, which is 2 minus 6 is minus 4, and we've got 8 plus 4 is 12, so we've also got a minus a third. So we've got these gradients are equal, therefore those lines are parallel. And that's all we have time for.
Thank you very much, Nina. Short and simple. Guys, thank you very much for tuning in, all you grade 11s. Up next, it is mathematics for grade 12s. And thank you very much to our sponsor, Macmillan. Hope you enjoyed, guys. Get those notes. You can still get them even right now. Up next, it is mathematics for grade 12s. Hope you're ready, guys. Cheers. Bye.